In this video, what we will do is go through the 5 different types of chemical reactions and learn how to tell one from another. And then the rest of the chapter is really about going into detail about them. So the first type of reaction that we look at is a combination or synthesis reaction. And just think of what those words mean, right? A synthesis reaction is where 2 elements or 2 small molecules come together to form one larger compound. Look over here, right? If we have, A plus B yields AB, or sodium plus chlorine yields sodium chloride. That's what a synthesis reaction is. You will see throughout this, what was oxidized and what was reduced. That's because when we learn that, I'm going to have you go back and answer that question about all these reactions. The second type of reaction is a combustion reaction, and you've heard of this reaction. So combustion reactions are very similar to synthesis reactions, but one thing that makes them different is that they must have oxygen gas as one of the reactants, O2. They also are all exothermic. So sometimes you can have, an element like hydrogen reacting with oxygen making water. That could be a combustion reaction, or something a little bit more complex. Here we have C3H8. That's propane. So literally the propane that's in if you have a gas tank at home for like a barbecue. C3H8 is what we call a hydrocarbon, because it contains hydrogen and carbon. And this is something you need to know. Every time a hydrocarbon reacts with oxygen, so every time a hydrocarbon is combusted, it always produces the same 2 products, carbon dioxide and water. So it doesn't matter whether we're talking about the Bunsen burner, which is burning the hydrocarbon CH4 or methane, your propane tank, C3H8, a butane lighter, which is C4H10, the gasoline in your car, glucose in your body. You always are making carbon dioxide and water. So that's combustion. Decomposition. Decomposition is the opposite of synthesis. Synthesis reactions are when 2 things come together. Decomposition is where one thing, usually a larger compound, breaks up into smaller compounds, or maybe even the elements that it was made up of, right? So here's BC decomposing into B and C. Here's an example of a decomposition reaction where it's mercury oxide is the reactant. You can see mercury oxide is like a orangish powder. And when we heat it up, often decomposition reactions will need some sort of energy to get it going. When I heat it up, it decomposes into regular liquid mercury. So mercury, that elemental mercury, and oxygen gas. Oxygen gas is given off here, coming out of them. That's an example of a decomposition reaction. And then the last 2 are very similar to each other, a single replacement, and then we're going to go into a double replacement reaction. So a single replacement reaction, think of the word single, that means one. One element takes the place of another element in a compound. So you can see here, let's say element C is all by itself. It's an element, and it is going to take the place of either A or B. It depends whether it's a metal or a nonmetal, which one it will take the place of. Metals replace metals and nonmetals replace nonmetals. So here you can see C took the place of A. These 2 switched places. So now A is all alone and B is combined with C. Here's 2 examples of that. The first one is a metal replacement. So we have the element that's alone is the metal. So it will take the place of, it will replace the metal in the other compound. So in this other compound, we have silver nitrate. So the copper will sort of boot out the silver, and the silver will be by itself, and the copper now will be combined with the nitrate. If what we have here is a nonmetal, like chlorine, when that reacts, it will boot out the other nonmetal. So then iodine, the nonmetal, will be by itself, and sodium will now be bonded with chlorine instead of with iodide. So metals replace metals, nonmetals replace nonmetals. And you'll always have to look at, how did you know, or how did we know that it was CuNO3 2? You'll have to look at what charge these metals make. And we'll learn how to do that in a bit. Here's another example of a single replacement reaction. This is the one where we watched a video of this, that Mythbusters video, where they put potassium and then strontium in water and saw it explode. So here's the potassium, that's the metal. It will take the place of hydrogen in water. And we're going to do this a whole bunch. We're going to rewrite water as HOH, hydrogen hydroxide. Remember, we've talked about how hydrogen can there's reasons why it's a really good fit right above the alkali metals, because in many ways it does bond and behave like a metal. But we classify it as a nonmetal because for a lot of reasons it behaves a lot like a nonmetal. It's diatomic, forms molecular compounds. In this case, it's going to sort of behave more like a metal because what we said was metals boot out metals. So then the hydrogen is all by itself here, hydrogen gas, and what is left is the potassium and the hydroxide. That's potassium hydroxide. Remember when we saw those reactions of putting the alkali and alkaline earth metals in water, what they formed was hydrogen gas, and that's what actually was exploding. Not the metal itself, but the fact that it would produce hydrogen gas. I also noticed that this reaction is not balanced. Let's go back and balance it. And in fact, if I use that trick of writing HOH, I may see that it's a little easier to balance. One potassium and one potassium. This, I'm going to underline hydrogen by itself in blue, and then I'm going to underline hydroxide in red. And if we count the hydrogens and hydroxides as separate, it can make it easier because now I see there's 2 blue hydrogens on the right. So if I put a coefficient of 2 here, that gives me 2 blue hydrogens, but it also gives me 2 hydroxides. And I put a 2 in front of the potassium hydroxide on the right, and then a 2 in front of the potassium on the left. Here's another example, right? Aluminum is a metal. So aluminum will replace the metal, copper. Copper will be left by itself. And now what will the other product be? What a lot of students do is they will do, okay, it'll make aluminum nitrate. Or they'll say, well, there's 2 nitrates on this side, so it'll make aluminum nitrate. And neither one of those is correct. You need to understand that aluminum now is an ion. And so because it's an ion, it reacts with the nitrate like an ionic compound, and we have to crisscross the charges to figure out what the product will actually be. There it is, aluminum nitrate, 3 nitrates. Everything in this reaction is balanced except for the nitrates. There's 3 nitrates on the right and there's 2 on the left. So I'll make them both 6. And now the nitrates are balanced, but I need to balance the aluminums and the coppers. And then the last type of reaction is a double replacement reaction. A double replacement reaction, think of the word double, you think of 2. 2 elements replacing each other, taking each other's place in compounds. So you can see from this graphic here, right, A kind of boots out C, and C goes and takes the place of B. It's like they're switching partners. Another way to think about this is to how do you know what the products are? You can think of it as like the middle part of foil, right? Foil first, outside, inside, last. So the outside guys come together, that's AD, and then the inside guys come together, right? It's always the metals first because students want to go, well, shouldn't it be BC? It's the metals first. So you can see, the calcium and the chlorine, the outside guys come together, CaCl2. And then the inside, hydrogen and hydroxide come together. That's HOH or H2O. That's the double replacement reaction. We'll learn a lot more about predicting the products for that in a moment. Here's a great example of another double replacement reaction. Look at what happens, right? The potassium and the nitrate come together, and the lead and the iodide come together. And again, we have to look at the charges, and we'll learn how to do that to figure out, what, and this one actually, we know the charges because we know that this lead must have been 2+. So that's how I knew that this was PbI2. And then in order to balance the whole thing, right, 1 potassium over here, 1 potassium over here, 1 iodide and 2 iodide. So I'll put a coefficient of 2 here to balance out the iodide. I'll put a coefficient of 2 here to balance out the potassium, and that automatically balances out my nitrates. So this graphic is really a summing up of all the 5 different types of chemical reactions. You can see combination and decomposition really are opposites of one another. Single replacement and double replacement are very similar, but single is starting with an element and double is starting with one compound and switching partners. And then combustion can often be seen as very similar to a combination or synthesis reaction, but you're always reacting with oxygen. And if it is a hydrocarbon, you're making carbon dioxide and water, and it's always exothermic. So this practice right here are just 5 chemical reactions, and you're being asked to figure out which one are the 5 different types. So if you want to press pause, go ahead and give this a try, and then we'll go through the answers together. So the first one I notice is an element and a compound, and I'm left with an element and a compound, and it looks like the lead and the copper sort of take each other's place. So this is going to be that single replacement or single displacement. Those two are synonyms for each other. The next one are 2 elements coming together to make a compound. So that's a synthesis reaction. This is a compound and another compound, and it looks like silvers with nitrate over here and silvers with iodine on the right-hand side. So this looks like double replacement. The next one has got oxygen as a reactant, and in fact it's a hydrocarbon reacting, making carbon dioxide and water. That's the definition of a combustion reaction. And then finally we have 1 reactant. Whenever we just have 1 reactant, the only type of reaction that has 1 reactant has to be a decomposition reaction. So those are the 5 different types of reactions, and you can tell which type they are basically by what are the reactants and products in it.